Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of laws of exponents. This is standard A.11B in the great state of Texas, and we are using item number 33 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got this expression, and all values of k and m are defined, and we need to simplify it to an equivalent expression. Well, this is something that we actually have in our reference materials, properties of exponents. And so let's use that as our guide here as we are working on this. Now, one thing that is going to help us is going to be separating this into like terms, right? So what I could do is I can reimagine it like this. 16 times k to the 9th times m to the 7th. Then we're going to put that over, and what I'm going to do is I'm going to put the like terms underneath, which they give it to you in order. You don't really have to rearrange it. But I want to make this multiplication visible, because what we're about to do is we're about to separate them into 3 separate problems. Right? Because what we can basically do is just chop that large division problem, that large fraction, into these 3 equal parts. And what you're going to get is you're going to get this 16 over 4 times k to the 9 over k to the 3 times m to the 7 over m to the 14. This is probably the hardest step, knowing that these two expressions are equivalent. And obviously, I chose the k's over the k's, the m's over the m's, because I wanted to have the same base, and I wanted to have the same constants together as the 16 and the 4. But if you can turn this into this, well, then you can handle each of these individual expressions separately. Becomes super easy, right? So let's deal with this first one here. 16 over 4 is just basic division. 16 divided by 4, so this is going to turn into 4. Now, this next one is going to be k over 9, or k to the 9 over k to the 3. So let's look over here at what we get when we get the quotient of powers, and I'll draw an arrow to it right there. What that says is that when you have a to the m over a to the n, that is equivalent to a, and then you simply subtract the 2. Right? So when you have the m as the numerator, the n as the denominator, just subtract the n from the m. All right, so we can do that. So I'm going to write that over here to the side. So k to the 9 over k to the 3, k to the 9 minus 3. All right, seems simple. So that's going to be k to the 9 minus 3, that's k to the 6. All right, so that's pretty simple. We have the same thing here, so let's do our m's. So it's going to be m to the 7 over m to the 14. You need to have the same base, right? So that's going to be m to the, don't flip them, that 7 is first. 7 minus 14. So this is where it gets a tad tricky. It becomes m to the negative 7. All right, so technically, this is correct. 4 k to the 6, m to the negative 7. You're not going to see it like that because there's one final step we need to do. It's that m to the negative 7, which is looking a little bit strange. And we actually need to go to another one of our rules, and that's this negative exponent. And that says if you have a to the negative n, really what you turn into, that's 1 over a to the n. So when we have this a to the negative n, it's that negative that makes it flip down into the denominator. So this m to the negative 7 is really 1 over m to the 7. So I need to bring this down, and really what you get is m to the 7, and now we see our answer there as B.